Another way to form new functions is using algebraic operations. Algebraic operations. Okay, so what do we mean by that? If you have two functions f and g, so we can form a new function called sum of those two functions. Okay, so f plus g is a new function. Okay, we can give it a name, but let's keep it like that. That assign for an x what the sum of the images by x by f of x and the image by g of these x, the same x. So like that for assign, we assign for each x a unique value, fx plus g of x. So we have new functions. We can define the difference of two functions, that how we obtain it, but just take computing the difference of the images. We can have the product of two functions, okay, by multiplying the y's, so the fx times g of x. We can obtain also the new function by dividing the two images, and we name the new function f over g. So for x we assign fx over g of x. Now let's pay attention here. We are dividing by g of x, so we need to eliminate the values where g of x is 0. So the domain of f over g, so let's put it to write it further. Okay, so the domain here, pay attention to the domain of f over g is the domain. We must take our x so that fx is defined, so we must be in df. We must be also in the domain of g so that g of x is defined, so an intersection d of g. Then we need also intersect also the set of x such that g of x is different from 0. Okay, so we need to eliminate g of x equals 0. But here you need the domain of the product function fg. We need to have the fx well defined, so we need to be in df. Our x must be here, and we need to have the g of x well defined, so we need also d of g, the intersection. We need to be both of them. Similarly for the sum and the difference, so the domain of f minus g is the domain of f intersect domain of g, and the domain of the f plus g function is the domain of f intersect the domain of g. So this is a way, okay, to have new functions. For example, remark, let's for example we have okay, we have polynomial functions. Polynomials, they are expressions like that. P of x en xn plus en minus 1 xn minus 1 plus etc. until we have a constant. Okay, so we are adding a constant function here, a power function with different powers. We multiplied by a constant function, and then we added all these functions. You see, we manipulated this operation many times here. Okay, we have rational functions, rational functions. So they have this form, f of x. It's the ratio of two polynomials, p of x over q of x. Again, here the domain, we need to eliminate the x's that are roots of the denominator. Okay. Yes, so this already, you see, we enlarged our family of functions that we know. Another way, another operation that will allow us to build more functions is the following one, is the composition. So composition, what is it? Maybe you saw it already, but sometimes we just say what is it. We don't give it a name. Okay, what is it? It is going here. Oh, okay. Okay, composition is so a way to form new functions. So we need to have the function f. Okay, let's say here new two functions. We need f for x. You assign an fx. Okay, then this is your y. Okay, then this y, it's a real number. So we can always decide to assign by another function g of y. I can do that as long as this real number is in the domain of g. So we need to have this y inside d of g. Okay, that means the fx must be in d of g. The x here is in d of f. Okay, as long everything has meaning, then we can make this corresponds from x. We will assign g of y, which is g of fx, and this is what we call GOF. GOF, the new function, the composite of f and g. Okay, it's a new function. So the domain of GOF is the set of the x's that are in the domain of f, starting point here. Okay, you start, sorry, okay, so we started using x here. Okay, here is our x here, and we want also that our fx to be here. Okay, so we need to be sure that our fx is in fx, it belongs to the domain of g. That's all. So you just express it well. And the definition, the main definition, GOF of x is the new function that we denote like that. It's just symbol. It's a new function. How it works? It is defined using f and g, the basic functions, f of x. So you take the image of x by f first, then by g. You need to be sure that these relations are well satisfied. Okay, so with this operation we can build many functions. Okay, so you know already many of them. For example, an example, simple example. Let's do one example just to illustrate this. So an example is, suppose that we have f of x equal square root of x and g of x, two functions, okay, is x plus 1. So we want to form f of g and g of f, okay. So g of f first. G of f, so g of f of x, okay. So by definition we said it will work like that, okay. So I need to check first my domain of g of f. We said I need first to take fx, so I need to be in the domain of f, so that my fx will be in the domain of g, like you read it in the order, okay. So your x, the domain of f, you have a square root, so it's inside 0 plus infinity, and the fx, when you compute which is square root of x, we want it in the domain of g, but the domain of g is everywhere, it's R. Okay, so as long, now let's check this set. What is your set? Now when I am looking for all the x's that are positive, so that square root, this is true. So my set, as long I am here, this quantity is in R, it's all those x's satisfy this this statement. So yes, my set will be this is set. Okay, and here is my formula now. It's so g of fx, g of this real number x plus 1, sorry, it's x plus square root. Okay, so it's square root of x. Fx is square root of x. Then g of the square root will be square root of x plus 1. Okay. Okay, and yes, and another last example, f of g of x. This time it's f of g of x. Okay, so let's look at the domain of f of g. Okay, the domain will be, so the x's, so that g of x, x in the domain of g, so that it will be well defined, so that this time f g of x, when you take the g of x, you want to take the image by f, it must be in the domain of f. Okay, so let's detail this, what we are doing here. Write it more in detail. So x in the domain of g, which is r, such that g of x is x plus 1. We want it in the domain of f, which is 0 plus infinity. The square root is defined in 0 plus infinity. And now this quantity is in 0 plus infinity if your x is greater than minus 1. So it will be minus 1 plus infinity. Okay, so here is my domain. You see how it is different. And the formula for this new function is f of x plus 1. And this one is square root of x plus 1. Okay, so here it is. So this is okay, so this is another way to get to form new functions. Okay, basic functions combined with geometric transformation plus algebraic operations. Okay, so you said here these were algebraic transformations, algebraic operations.